this is much as for you to ask changes, but also get insights into what we've done over the last few months. A lot of people have been involved, and it's to give credit to those that we release it. So what am I going to show you? I've got a spreadsheet, and that spreadsheet has a whole series of information in there. That information is a list of all the changes that we've actually made in the since the last release. So let's say welcome. So my name, as I said, my name is Evan Venn. I represent the development team, but this is the first time we've ever done this, so we'll give it a go. Right, so what we've got is about 50 changes. I think there's another handful to come through, and they're all indexed in here. So if you want to ask any questions, I can pick them up. Let me just see. I can pick them up on the web here, so that's great. Any questions coming in, you just chat away and try and pick them up. So let's just get through, and we'll give you some examples of what's coming through. So these are the numbers, the change numbers. This is the type, new or a fix. This is the scope, and this is just a tracker for me, just whether I've shown it or not. Okay, let's start with the core stuff inside of the compiler. Okay, so the compiler has got how many changes in there? 14 changes in there, and there's a load more to come, about 3 or 4 more to come. Let's just go through the really big ones, okay? So really big one, 648 is quite important. 648 enables you to use another tool. So we've actually added another parameter to the compiler, and that enables you to use a different tool to discover information about the chip. So this is quite a big change. It's called pick info, and if you just type in, these are all the chips that it now supports. So this switch at 648 enables us to produce this set of data that can be sucked into this tool called pick info. So if I type in a pick name in here, it will take me to the pick. And if I just zoom in on that for you for a minute, okay, there we go. I'll zoom in. If I double click it, it then tells me all the parameters with respect to that chip. So all the defaults, you can see the defaults here. So if you've ever wondered what defaults Great Cloud Basic will pick, they're in here. And if you want to play with them and change them, then please do. You can come in here and say, I want clock enable on. You can then copy that out, and let's just put that in Notepad so you can see it. It's just put that information directly into Notepad for me. So one of these changes enables this tool to be used, which is great, and a couple of those others are also in support of that. Let's look at other places, other stuff that's going on. Inside of the compiler itself, if you generate some source code, let's just generate some source code here. Just generate some ASM for you, and inside the assembler now, you can you now get a listing of where that source file is coming from. So you can see in here, if I zoom in on the scene right there for you. Oh, forget that little camera there. Sorry about that. That's from earlier on. There's a line. These source lines are now in here. So if we do a search for source, we can see that that's this one here is actually in the source file itself. This one here is in timer.h, and it tells you the line number. So this is a great addition to the toolchain. We fixed some bugs in the K42, K83 bugs, and that's a new capability. But let's just take you through a huge change in the compiler. Okay, so I'm gonna try and do this for you. All right, let's have a look at some source code. You can now specify, rather than struggling with decimal numbers inside of the chip for the frequency, you can now specify parameters like 31K. you can specify 32.768K, 125K, 250K, and 500K. So if you put in 500K in here, it will, let me just generate a hex file. It will automatically pick it up, and inside of the bottom line, it will tell you the frequency. Now we're going to zoom in on that to show you that line, because that's quite important. You can see that it's now calculated that at 0.5 internal oscillator. Now that's quite important, because this is a new capability in itself. This line here where it says oscillator, that's new. The selected oscillator setting has been displayed for you, and then the frequency. So you get a very good handle on what's actually happening inside of the chip now, okay, inside a compiler. So I put there 125K, generate some code. It tells me that, oh, I put an error in there, by the way. That's why it's come up with that. 125K. It's come up and said 0.125. Now, what is really very different about this this version of the compiler, if you put in a 31K in here, 31K is an internal oscillator, but it hasn't been supported in the past. So let's have a look what that does. It's generated a new command line for you, and let me zoom in on that. And you can see here it's now pre-selected the LF interrupt for you, oscillator, and set it to the correct frequency. So we've now added in LF int as a supported frequency. Now, what's important also in these major changes in the compiler, in the clock stuff, if you put in here a frequency that is not supported, this is very important change. I'm putting in 24. And if we look at that bottom line, 24 is supported by this one. Let's just make sure it's not supported. Great. So if I zoom in on a frequency that is not supported by the chip, you will see it now says oscillator 20. The clock source is not a primary internal oscillator. Ensure the clock source is correctly set up. So you must set up that clock source to make it work. Otherwise, it won't work. Now, what is also different in this version of the compiler is that if I look at the setup inside of the assembler, there is nothing in here that sets the chip up. You are now we do no longer interfere if it's external. So we don't do any settings on the frequency settings anymore. So let's take one that a sample external. If I take a Q10, this is a Q10. If I compile that up, it says at the bottom. Let's zoom in on that. It's got the correct clock source selected. It's got it says it's not a primary oscillator, but now I've got a load of settings that I put in there to support that clock. Okay, that clock is now properly set up. Okay, now if I take this out, compile it up again, because you might have a very accurate 16 megahertz clock source. If I zoom in on that for you, it says internal. So the key thing in here is that the oscillator setup has changed. It supports LFINT. It supports LFINT much better. Supports these frequencies in the command line, and it sets up nothing in the assembler if you use an external frequency. Let's keep going. What else have we got in here? We have also fixed a major issue in the K42 chipset in terms of the assembler. previous to this release, it wasn't working correctly at all. We've now changed the code, and we have extensive handling now for the K42. And I was looking in here for some K42 code. Oh, here we go. Look. We now store away all the correct buffers and registers. We were not doing that correctly in the past. We've also exposed some other constants for you, so called chip oscillator and chip using int oscillator, so that you can actually do some other work with that. So let's rip through what else we've got. Let me just uncheck that. We're going to look at converters. We won't touch that. On the DAT files, we've updated to MPLAB 5.5885. Sorry, that there may be other stuff coming through as we talk about it in the next few weeks. Okay, let's look at some other key areas like the communication protocols, I2C and SPI. New capabilities. There's a new fast mode for SPI on some chips. You have to go and figure out whether it's on those chips. And we've actually improved the outer band. So if you have an outer band where the calculation or the frequency of the chip is too slow, then it will now issue an error message. In terms of GS tools, the IDE, language support, let's have a look at what all that stuff is, okay, and the website. We'll do that in one big lot. We've now got a BSD download up on the forum. You can see that. We now don't maximize the help, okay, and we've actually improved the performance of when you do a make hex. It's a lot faster. Now I've done a speed test today. The speed has improved on the compiler. It's 8.8 seconds now for the standard test, and it was 17.4 before. So that's approximately 50% quicker. So the compiler is getting quicker and quicker and quicker. We've actually updated a little issue inside of the programmer as well to support AVRs. Let's have a look what else we've been up to. We definitely fixed EEPROM. Yeah, we fixed the EEPROM stuff. The K40s weren't writing the tables correctly out to EEPROM, but they are now. That's been fixed quite nicely. Big one, really big one here. LCD. Okay. Now, Bill has spent an extensive amount of time improving the performance of LCD. LCD is now up to 35% faster, and there's a load more settings, so you have to go check out the help. But essentially, the LCD is blindingly fast compared to it was before. Okay, so LCD has been updated. Whilst we're on those sorts of things, we'll have a look at GLCD as well, shall we? Yeah. We've got a new driver for a very small Adafruit display, very nice. New e-paper drivers, very nice as well. That some of them use RAM, some of them don't use RAM. There's double buffering on them. A new UC1601 library. I've mentioned that Adafruit already, and we've updated a number of the other libraries to improve their quality. So there's been a busy time in GLCD over the last couple of months. In terms of other libraries, I think we ought to sort of look at libraries in themselves, okay? So we've actually improved HCLSend to support some level of optimization to get the code level down. We have a new library for SRAM being added in. You can just look at the help and demos. We've revised the K42 to prevent it from sending data out inappropriately, okay? And there's a brand new SPI RAM as well. So there's a few more libraries being added in, all in the help. You can see it in the help itself, okay? All right. In terms of other stuff, okay, that we've been busy on. Oh, that's quite an important one. So we've actually improved, and this is a catch-all for a lot of other changes. We've revised the headers to give us the copyright. Okay. The UART, I mentioned that. Now, Core 16, there was a low-level assembler problem in Core 16 chips. Been there for a long time. Okay. We've also added AVR as a programmer inside of, so you can use PicKit 2 as an AVR programmer. We've also released this, which is quite cool. Now this is a set of reserved words. Okay, so we've now defined reserved words. Didn't mean to do that at all. You've now got a set of reserved words. Now these reserved words can be used by yourself for any sort of syntaxing, etc. Let me just cancel that down. So these reserved words are extensive. As no one's watching this, I don't believe anybody is watching this video. Pretty disappointing. Let me check my mobile phone because it has been beeping. See if I'll be getting messages up on my mobile phone. No. So I'll crack on and carry on anyway. Yep. So what's key about some of this stuff is that you get your hands on it. I'm just looking down here to see what else I should be showing you today. USB we haven't discussed, system we haven't discussed, and program we haven't discussed. So right across the whole tool chain, we've actually revised the headers. We've now got a set of signed USB drivers for libk and USB. And as I said earlier on, we've changed the system.ini to help us change the clock sources. So what we've done is we're talking here about Great Cow Basic, which releases it. 98.07, 0.98 is the release. Let's zoom in on that for you. Yeah, that's off the screen slightly for you. Bad luck. We'll go to desktop. I think that's the right way to do it. Yep, there we go. It's a 0.9807. So what we've essentially done this time is we've got a whole series of changes that we've made. They cover most libraries have been updated, big changes inside the DAT files, lots of changes inside the compiler, which I've introduced. The big ones are inside of the clock frequencies. GLCD has been updated. A lot of the code has been changed and improved to take out superfluous commentary inside of the assembler. So for those who like wading through the assembler, we've really come through and cleaned it up. So if you do a compilation with no basic in there, let's have a quick look at that. There we go. You're getting pretty clean code. If we look at something like init.sys, you're just going to get these few comments now. Okay, so for the selected frequency, the external oscillator has been selected by the compiler, and it says 20. Okay, complete the chip setup. You know, That's all that's in there. And down here, in that, if we zoom in on Sin, right, you can see it says clock source is not primary. So ensure that the clock source is set up correctly. We are leaving that up to you now, okay? Yeah, you guys have got to sort that stuff out. I'm just changing that back to 31K, and you'll see now 31K. If we look back in the assembler, back into that assembler, you can now see there's a section in there. It says this code block sets the internal oscillator at the correct frequency. This is the actual text it's put out, and these are the settings that we've assumed. Okay. Now, there's a lot going on in the background to make this all happen. Okay. So inside of the, if I show you inside of this new tool here, there is an awful lot of stuff that's been added in here to make this all work. So this is the header. Is it the header? This is the header. So the header has a number of other parameters in here that you can find. Okay, all right. So we've updated help, we've updated installer, and we've only got a few more issues to sort of resolve before we're actually done. So I thought that'd be quite good to give you a quick update on what we're doing with Great Cow Basic release 98.07.